Hi everybody, we're going to talk about the 8th grade Common Core notes for 10.1 and 10.2, exponents. As we go ahead and we look at the example of what the vocabulary that's going to be used, it's very important to know that 1/2 to the 5th power is represented by a power, and we refer to it as a power. The 1/2 is referred to as the base, and the 5 is referred to as the exponent. So when we say 1/2 to the 5th power, we're saying the base is a half and 5 is the exponent, and 1/2 to the 5th power altogether is called a power. There's two rules that you need to be familiar with. Both of the rules have A as their bases, and those bases are the same. So when a base is the same and it has an exponent and they're being multiplied, you simply go ahead and add the bases for a sum, and then the base stays the same. Compared to when you're going ahead and you have a base and a power that is raised to you have a base with an exponent raised to another base, you're simply going to be multiplying. So we're going to run through a bunch of examples as to when you're going to be adding those exponents versus when you're going to be multiplying those exponents. So the same rules apply. Everything I write down, you write down. If at any point in time you didn't understand, I suggest you hit pause, go ahead and back and rewatch. You also should be writing questions on either side or sending emails regarding what those questions are so you can come prepared to go ahead and discuss the notes in class the next day. So my first example is going to be pi times pi times pi times r times r. And in this case, I'm going to ask that this be written using exponents. So I can simply say that there are 3 pi's and there are 2 r's. So if they are given an expression and they are asked to write that expression using exponents, I literally count how many pi's are, and that is represented by the exponent of 3. I count how many r's are, and that's represented with an exponent of 2. The same thing can work when you have fractions. So if I have negative 1/3 times negative 1/3 times negative 1/3, I literally am multiplying negative 1/3 3 times. So I have to go ahead and say that I'm multiplying negative 1/3 to the 3rd power because it's 3 times. I want you to pay attention to this part right here because if you notice, I included a negative inside my parentheses to represent that the entire base is negative 1/3 and not just 1/3. So because these bases are negatives, my base must be indicated with a negative, and I do that within a parentheses. All right. For example 3, if I were to go ahead and negative 4 to the 3rd power, what does that mean? That means that I have negative 4 3 times. 16 times 4 is negative 64. So this direction would be evaluate the expression. All right. So these two are writing expression, simplifying the expression using exponents, and this example is evaluate the power. In example 4, there is a difference, right, in where the actual negative goes. This is telling me I'm multiplying negative 4 to the 3rd power. So negative 4 times negative 4 times negative 4. In example 4, this is saying the opposite of 4 times 4 times 4. So if I were to go ahead and write that out, 4 times 4 times 4, it is 64. The opposite of 64 is negative 64. In this case, the answer ends up being the same. If it was an exponent of an even number, the answer is going to be different. So please pay attention to where the negative is located inside the problem. For example 5, we're going to go ahead and start using those rules. If we were to go ahead and have negative 3 to the 2nd power times negative 3 to the 4th power, I can go ahead and do what I did in example 3 and 4. That means I have 2 negative 3's, and I'm multiplying that by 4 negative 3's. And that's totally acceptable. Or I can use my rule. And my rule says the bases are the same, and they have to a power of 2 and a power of 4. So that means I can go ahead and say negative 3 to the 2 plus 4 power is negative 3 to the 6th power. They represent the same thing. So what I went ahead and did is, rather than writing them out, I went ahead and added the exponents because the bases were the same. So if it asked you to evaluate, you would have to evaluate, or you can go ahead and leave it as that exponent of -3 to the 6th power. You have to pay attention to the directions. Example 6 works similarly. I have -2 to the 3rd times -2 times -2 to the 4th. Now, I can go ahead and write out -2 times 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 -2. I think I said that right. Or I can simply say -2, 3 plus 1 plus 4 is -2 to the 8th power. By going ahead and simply adding my exponents, I can go ahead and write the base with the sum as the new exponent. So example 5 and example 6 refer to this power rule. When the bases are the same, you can simply add the exponents. Now let's talk about the other rule in example 7. For example 7, the bases are still the same, but this time I'm multiplying. These bases were being multiplied, but this is being raised to another power. So for this, rather than adding 5 plus 4, I have to multiply 5 times 4. And so my answer is W to the 20th power. My base has an exponent, and that power is being raised to an exponent. So I simply multiply. In example 8, it works the same way. 2W to the 4th. But because I have a coefficient of 2, 2 is to the 4th power, and W is to the 4th power. And I can go ahead and simplify that. 2 times 2 is 4, 4 times 4 is 16. If I would be asked to evaluate, my answer would be 16 to the 4th power. These two are based on a power being raised to an exponent. So I literally go ahead and apply that exponent by multiplying it to by every exponent that's listed in the power. It even works for fractions. So if I have 1/5 k to the 2nd power, every single term, every single part of the base needs to be raised to the 2nd power. So I have 1 to the 2nd power, 5 to the 2nd power, and k to the 2nd power. Now in this case, I'm going to evaluate. 1 squared is 1, 5 squared is 25, and k squared is, or k to the 2nd power is k squared. So, examples 7, 8, and 9 apply to a power to the having an exponent. So you literally multiply the power, the exponent to the exponent, but you have to apply it to every single thing that is part of the power. So I multiply it to the W, and I multiplied it to any coefficients that are there. So, big picture. If you're not listening with volume, you're missing some of the things that I'm saying. If you're not watching the whole thing, you're also missing things that I'm saying that are going to be important. All 9 examples need to be written down. If at any point you have any questions about what I'm doing, you have to go ahead and send an email or rewatch or write notes in the comment. All right, guys, have a good one.